All right, let's pick up with our chemical methods of control with our alcohols. All right, alcohol, only ethyl and isopropyl are suitable for microbial control. And we consider this alcohols to be an intermediate level. And notice it says concentrations of 50% or higher dissolve the lipids in the membranes. Remember the phospholipid bilayer, and they coagulate proteins. And notice it says water is needed for proteins to coagulate. Thus, alcohol shows a greater microbial activity at 70% than at 100%. So again, if you think about the alcohol that you use to say wipe my skin down before inserting a needle, whether it be a blood draw or giving me a vaccination, you typically use 70%. Sometimes you use 90%, but you don't use 100% because that actually is more damaging to the skin. So alcohols are considered an intermediate level disinfectant. So, example, nurses take advantage of alcohol gel hand cleaning stations. These are very, very common both in hospitals and clinics. And again, this is to try to help promote hand antisepsis. Hydrogen peroxide. Wow, one of my favorites. And the reason is because, notice it says it's antiseptic at low concentrations. So when you use hydrogen peroxide, H2O2, we know that the oxygen, the O2, is going to start to bubble out. That's the bubbling, oxygen gas, and you're left with water. And we know that most organisms, if you remember from previous topics, we know that, I think it was chapter 7, most microbes cannot handle oxygen environments. So oxygen is toxic to them. And so hydrogen peroxide is by far one of my favorite chemical controls. I'm sure if any of y'all have contacts, you've seen the bottle of contact solution with the red lid. And again, that bubbling that is produced is oxygen gas, and then what you're left after about 6 hours is just water. And thus you can just rinse it and, you discharge it, throw it down the sink, the water down the sink, no problem. And it has disinfected your contacts. So, looking at your alcohols and peroxides, again, remember that with alcohol, it typically works better if it is mixed with water. Therefore, a 70 to 90% solution is your best option. 100% is not desired because it actually desiccates your skin. Isopropyl alcohol, that's what I was talking about there as well. Ethyl alcohol, grain alcohol can be used as well. So back in the old days, you would see them sterilize an instrument by pouring some whiskey on it. That would be your ethyl alcohol. Hydrogen peroxide, again, 3% hydrogen peroxide solution is plenty, and the bubble gas that's given off is your oxygen. And again, then ozone would be another form of a oxidizing agent, but again, it's difficult to handle in gaseous forms, therefore it's usually used more in industry. Okay, aldehydes. Now, aldehydes are different chemically because they kill by alkylating proteins and DNA. And so basically what happens is that they change their chemical structure. So the example is glutaraldehyde and formaldehyde. And so these are high level, intermediate to high level chemical controls. And so typically your glutaraldehyde is used to sterilize heat sensitive instruments, maybe that are used in surgery. Okay. And formaldehyde, obviously we remember, used to be a preservative that we embalmed bodies, right? And so when we do dissections and things like that, again, because they're intermediate to high level, they inhibit microbial growth. But again, you got to be careful because then their toxicity. So yes, they're intermediate to high, but then you have a better or a higher risk of them being toxic. So notice it says technician treating surgical instruments with glutaraldehyde before heat sterilization. All right, so what about gases? These are ETO, ethylene oxide, and PO, propylene oxide. You can use also carbon dioxide. These are, believe it or not, high-level chemical controls, and they're used to sterilize and disinfect plastics, prepackaged devices, and food. So think about that. We can't use a toxic chemical on those, but we can use these gases to sterilize them. And then this kind of shows you, so anytime you open up a packaging, they have used these gases, usually ETO, to sterilize them. And then again, giving you the chart, it kind of gives you some examples of what's used and when this is used. Okay? Detergents and soaps. Detergents and soaps. These are going to be very low level. Thus, we find them everywhere because they're safer for the average person to use. So detergents and soaps serve as a surfactant. And what that means is that they're going to disrupt the membrane. They're going to disrupt the membrane. Soaps are alkaline. That means they're slightly basic. And soaps are used to remove soil and grease containing microbes or microbes that are found in that. It says certain weak microbicides, things like meningitis, gonorrhea, syphilis. Some soaps can work on that, but only if they're highly sensitive. So I love this little chart because one of the questions that I've been asked before is, well, Miss Bradley, should I really use antimicrobial soaps all the time, since they're always talking about resistant strains and how we're creating all these resistant strains? And so by looking at this chart, one of the things that I like to point out is that notice the number of days. Okay? So what about me and you? We probably bathe every day, don't we? Right? We probably, when I say bathe, shower, whatever, clean ourselves every day. Well, if we clean ourselves every day, the likelihood of really needing a germicidal soap is fairly low. Notice that after day one, right, one day, the slant, the slope of the lines is about consistent. So if you think about the number of microbes, they're pretty much killing the same amount. The key is that if you and I were to go more than one day without bathing, notice that our bacterial load would increase dramatically if we had used non-germicidal soap. Whereas if we do use germicidal soap, you can go several days without seeing the microbial load increase. All right, Ms. Bradley, what does that have to do with anything? Well, I think the thing that I want to point out here is that think about who your patient is. Let's say that you're working in a home health and you're dealing, say, with an elderly patient who does not like to bathe, or maybe it's the wintertime and they don't want to bathe as often. Well, then by all means, I would recommend using germicidal soap. Right? Go on and invest. Tell them to invest, because they're going to see that their microbial load would not increase over maybe a day or two without, taking a true shower or bath, that the load would not be as high. But for me and you, just average taking a bath every day, then I don't see that it's necessary to use a germicidal soap. Again, here's the table that talks about how it's delivered and what are some of the applications. All right, so clearly you wash up, scrub up before going into surgery or going into a procedure. All right, so let's see how we do on this one. Which of the following kills by producing oxygen radicals? Oxygen gas, oxygen radicals. And hopefully you said hydrogen peroxide. All right, excellent. All right, so we're going to finish out this chemical controls real quick, and then we're going to go to something else. Heavy metals, things like silver, mercury, gold, These kill vegetative cells in low concentrations by making the protein inactive. And I'm going to show a picture that to me helps with that. So this is things like silver, silver nitrate, things like that. Okay, so think about your teeth, right? Fillings are often made like gold teeth or silver fillings. So why would those be used, right, in our mouth? Well, if you think about it, those metals are going to inhibit bacterial growth, and you see the zone of inhibition around where this silver amalgam is. Notice the microbes are not growing as much. Notice the gold. And the reason for that is that they actually denature the proteins, and I guess the image is not here, but they denature the proteins or warp the proteins out of shape, or they occupy an active site, which then keeps the protein from being able to, the enzyme from being able to work. And so this is why heavy metals are useful for chemical control as well. And then finishing up, dyes and acids and alkalis. So your dyes are typically going to work with your gram-positive species, and sometimes these are used for antisepsis and wound treatment. They are low level. Okay, so they're low level and they have a narrow spectrum of activity. Your acids and your alkalis also have a low level of activity, and so they're going to inhibit bacterial growth some. And so, for example, what I think about here is, how many of you have seen people with athlete's foot or nail fungus, and they talk to them about soaking their feet like in Listerine or in mouthwash or something like that? Well, very often those are acidic, right? Solutions, slightly acidic, and or vinegar. And these things would be a low-level activity, but then they would be able to kill off some bacterial growth and some fungal growth. Okay, so again, great table. Try to showing you some of the products that you and I use on a daily basis, and specifically what category, antimicrobial category, do they fall into. All right, that wraps up chapter 11.